Hello class, this is the video for section 11.1, and in this chapter 11 it talks about systems of equations and inequalities. We consider only one section in this chapter, and that is systems of linear equations. Okay, we're going to be using two methods, the substitution method and then the excuse me, the elimination method. Now, elimination method is the same as the addition and subtraction method. Sometimes some textbooks, that's how they call it. Okay. Now, this video, there will be two parts. In the first part, we will look at the following learning objectives: solving the system of linear equations by substitution and by elimination, and able to identify inconsistent system of equations in two variables, and then expressing the solution of dependent system that is also involving two variables. And then the second part, we'll look at the same using the elimination and substitution involving three variables, and also inconsistent system of equations, linear equations, and expressing the solution as of dependent system. Okay. So first, let's start with identifying what is a system is of this form, so it comes in this form, and whether it's linear and how many variables are involved. Now, as we look at this is how I tell my students that it's linear, or is the equation of a line. You can put it in the form y is equal to mx plus what? Plus b. Okay, you can put in that form, or look at the exponents. Okay, for it involving two, look at the exponents of y is 1, x is 1, y is also 1. Then the other equation, the exponent of x is 1, exponent of y is also 1. So this is what linear involving the two variables, x and y. Okay, so that's equation 1, equation 2. The second example, okay, this is involving the two variables, x and y. This is not linear, but it is two equations in two variables. Okay, it's not linear because of what? The s squared. Okay, the exponent makes it what? A quadratic. So this is the first equation is quadratic. The second is what? Linear. So this is quadratic and linear together, but it is a equation in two variables, and this is not what? Not linear. So the system is not what? Linear. Okay, so take note of that. And then the third example, how many variables are involved? We have x, y, z. The exponents of each of the variables in each equation is 1. So this is what? This is linear, involving three variables, x, y, z. Okay, so this is yes, this is what? Linear equation or linear system. All right. And then the third one, okay, how many variables are there? The second equation has only two variables, x and y, but the whole system has what? Three variables, x, y, z. So this is also linear. Okay, this is linear. All right, this is linear. And then the last but not least, how many equations are there? We have what? 1, 2, 3, 4. How many variables are there? We have what? X, y, z, x, y, x and y, and it's just x. So this is also 4 equations in what? In 3 variables, x, y, z. All right. So now, if you solve any system of equations, whether it's linear or quadratic, there are 3 possible solutions. If it's a linear, and that's what 2 variables, you have 2 lines, okay, that will intersect at a point, and that is the point of intersection is what is a solution, because at this point you have the coordinates in the form x and y that satisfy both what equations. Okay, or you may have parallel lines, and that system, the lines, when you draw them on the graph, they never intersect, they don't meet. So that is a system that has no solution. Okay, and it's also called what? Inconsistent system of equations. And then third, you can have consistent and dependent, because the system, the equations that you have, it is just the same one line because the solutions coincide. And if you have a line that have many points on the line, since they are infinitely many, therefore this equation, this system has what? Infinitely what? Many solutions. Okay, we'll look at examples in each. All right, so first, let's look at this system of equation. It is linear and it's a 3x minus y equal to 5, and then x plus what? 2y is equal to what? Negative 3. Now, I'm going to use the same equation, this system, for the method of substitution, for elimination, and just to show you that it does not matter which method you use, you get the same what? You get the same solution. So we want to start with graphing. I mean, solving this system by what? By graphing. Okay. So these are lines. So we first is that we're going to put each of the equation in the form of in the slope intercept form. Okay. Well, after that, then we graph each line and then see their point of intersection. Okay. So for the first equation, which is what? Which is a 3x minus y is equal to 5. Okay. From this, if you solve for y, you are going to have, if you take the 3x to the other side, you're going to have what? Minus 5 plus what? 3x. Or simply it's going to be what? Y is equal to 3x minus what? Minus 5. Where you have the slope, okay, and then the y-intercept. Now for the second equation, you have, if you solve for y, you're going to be y is equal to minus x, or 1 over 2x, then minus 3 over what? Over 2. Okay, so for this equation, you have this system. So when you put in this, you can find what? The graph, you have you have the slope, and you have what? We have the y-intercept. Okay, but I'm going to use points where I want to avoid the fractions, especially the y or intercept for the second equation, because it is hard to sometimes graph the points like that if it's a fraction. For example, if you have like 1 over 1/3, how do you plot this on the graph? Okay, so first we want to look at, we'll pick for the first equation, which is 3x minus y equal to 5. We want to get an ordered pair. Okay, this is x and that is y. So I'm going to pick a x and y intentionally so that I will avoid what? Fractions. So for example, if x is 2, okay, if x is 2, what is y? You get y is going to be what? 1. Okay, and then if x is 3, you have any 3, you get y is equal to 4. So the ordered pair, or the point with the coordinates x and y, this is 2, 1, and that is going to be 3, 4. Okay, so for the other one, we have x plus 2y is equal to negative 4, negative 3. We repeat the process. I pick values of x and y so that I'll avoid fractions or decimals. Okay, so I'll pick a 3. If x is 3, then what is y? Okay, if x is 3, y is equal to negative 4, negative 3. Okay, because if you have 3, you get minus 6, and you divide both sides by 2, you get y is equal to 3. And then if a y is 0, x is equal to what? Negative 3. So this gives me these points with the coordinates. Okay, 3 minus 3, negative 3. And then we have what? Negative 3 and 0. Okay, so we're going to plot these points. When you plot the points for the first equation, which is equation 1, and that is the equation 2. So if you plot them, okay, these are my points. Okay, negative 3 for this, for the second one, negative 3, 0, and then I have what? Positive 3, negative 3. That's the point. So you plot these points and join with a straight line. For the second equation, the first equation, when x is equal to 3, 2, okay, y is equal to 1. So I have this point, and then I have 3, and then 4. I have this point. So we get that line. So look at their points of intersection. What are the coordinates of this point? Okay, the x is what? X is 1, y is what? -2. And this becomes what? The solution. Okay, that's the solution to the system. Okay, we can check and see if that is correct. Well, we have 3x minus y equal to 5. When x is 1, you get 3 times 1 minus 2 is equal to positive 5. And that gives me 3 plus 2 equal to 5. And that's check. For the other one, we have for x plus 2y is equal to -3. X is 1, you get 1 plus 2 times -2. All right, you get 1 minus 4 is equal to -3. So you get -3 is equal to -3. So that's check. Okay, so using the graph, we can what? We graph the lines and then read the coordinates of the points of intersection. That will be the solution to the system. Okay, now we take the same equation, the same system, I mean, and then we solve by what? Substitution. We solve by substitution. We go through some steps. I'm going to go through some steps for this first example, and then also steps for elimination. But subsequent examples, I want to put all this, I will go through each steps like that. In other words, I will not separate them. I will lump all the steps together and show you how to do things. Okay. All right. Now, if you have this system, step 1, it says solve for one of the variables, okay, in terms of the remaining variables. So there are 2 variables here. I look at equations 1 and 2, all right? I don't want to have fractions. I don't want to have decimals as well. So I want to pick one of the variables so that the equation that I get will not involve in what? Fraction, all right? So for example, from equation 1, if I look at y, I can solve for y. Equation 2, I can solve for x, so that x will be equal to -3 minus 2y. And I wouldn't have to what do you call it? Get involved in what? Fractions. So this is what I mean. So from equation 1, all right, let's solve for y, for example. Let's solve for y in equation 1. And from equation 1, we have for 3x, all right, minus y is equal to what? 5. So we are solving for y. Okay, I can add y to both sides, okay, plus y. So I get 3x is equal to 5 minus y, okay, 5 plus y, and then my y is equal to, will be 3x minus what? 5. Subtract 5 from both sides, okay, and that will give us that answer, give us this value. So we have this equation. We can call this equation equation what? 3. It is an equivalent equation from the equation 1. So let's label that equation 3. All right, then we go to the second step. It says substitute the result in step 1 into the remaining what? Equations. So what we do is that we're going to substitute, we will substitute, okay, substitute what? Equation 3 into equation 2, because okay, we substitute that into equation 2. So that means that what is equation 3? Equation 3 is y is equal to 3x minus 5. Okay, we plug it into equation 2. Now, what is equation 2? It is what? X plus 2 times y is equal to -3. So we have what? X plus 2 times y, and then y is what? 3x minus 5 is equal to what? -3. Okay, so once we have this, you see that we have one equation involving only one variable. Then we solve for that variable in the next step. Okay, so if one equation in one variable results, then solve this equation. Otherwise, repeat steps 1 and 2 until that happens. Now that will occur when we get to have more than 2 equations in a system. Okay, so what we have there is that we have what? X plus 2 times 3x minus 5 is equal to -3. So we are solving for x. We distribute, okay, that will give me what? 6x minus 10 is equal to what? Negative 4. This is negative 3. And then x plus 6x is what? 7x minus 10 equals negative 3. All right, we add 10 to both sides. All right, and then we get what? 7x is equal to what? 7. Divide both sides by 7. Okay, you have x is equal to what? 1. Okay, now once you have x is equal to 1, then we're going to substitute this into equation 3 because we have that one involving y is equal to. Okay, so find the values of the remaining values in the by what? Back substitution. So now substitute okay, x is equal to 1 into, I'll call it the one I labeled equation 3. What is equation 3 was y is equal to what? 3x minus what? 5. So when x is equal to 1, y is equal to 3 times 1 minus 5, which is what? Negative 2. Okay, so once we have that, then what is our solution? Okay, solution is an ordered pair, and that is what? 1, negative what? Negative 2. This is an ordered pair. It's always an ordered pair. Okay, it's always an ordered pair. All right, so we can check our solution again, and I will leave that for you. Check your solution for this. Let's look at it. If x is 1, you get 3x, that is times 1 minus y, which is negative 2, is equal to 5. And then that gives you 3 plus what? 2 equal to 5. Okay, for equation 1. And then equation 2, you have x plus 2 times 2y equal to negative 3. That gives me 1 plus 2 times minus 2 is it equal to negative 3. All right, this is 1 minus 4 equal to negative 3. So like we said, get negative 3 equals negative 3, and that is check. Okay, so again, our solution set is what? Is that. So the solution is 1, negative 4, negative 2. All right, so now we'll pick the same equation, sorry, same system, and then solve using what? Elimination method. Okay, but before that, when you get the equivalent, what we call the equivalent system of equations, if you do any of these following, it gives results to the system. So if I multiply an equation by a non-zero constant, okay, if I solve that, it will be the same as the solution to the original what? System. So if you interchange any two equations of the system, okay, it results into what? An equivalent system of equations. Or if you multiply or divide both sides of an equation by same non-zero what? Constant, okay, you don't want to be 0, because if you multiply something by 0, you get nothing. Or if you replace any equation in the system by the sum or the difference of that equation and a non-multiple of any other equation in the system. Now, any of these processes gives us what we call an equivalent what? Equivalent equations, or equivalent system of what? Equation. All right. So this is what we do using what? In elimination. So you see that it's the same system, 3x minus y equal to 5, x plus 2y equal to negative 3, equations 1 and 2. So we want to see if I use the elimination method, will I get the same thing, same solution as we got, 1 and negative 2. Okay. So now step 1 is that multiply both sides of one or both equations by a non-zero constant so that the coefficients of one of the variables are additive for the inverse. Now I want to say additive inverse. All right, additive inverse, that is if you add them together, you get 0. So if you have a, the additive inverse of a is what? Minus what? Minus a. So if you add a to minus a, you get what? You get 0. Okay, so for example, minus 2, the additive inverse of negative 2 is positive 2. So plus 2 gives me what, 0. So, all right. So if you look at this equation, all right, equations 1 and 2, and I'm looking at the coefficients of the variables x and then y. Now let's say that I want to eliminate y. Now because this is 2 and it's positive 2 and this is minus 1, if I multiply equation 1 by positive 2, I'm going to have 6x minus what? 2y, so that when I add 2y to positive 2, these two becomes what? Additive inverse. And then I'll be able to what? Eliminate the y from the two equations, solve for x, and then substitute into one of the originals and get and solve for what? The y variable. Okay, so he said the first thing is that you do that. Now, if I want to eliminate, okay, if I want to eliminate y, what I said, you multiply both sides of the equation by what? Positive 2, all right? So that the coefficients of them becomes what? Of the y in the two equations are additive or inverses. Okay, so what I'm doing is I'm going to write this form, okay? So we're going to multiply. When I write this, that's multiply by what? 2. And this becomes what? 3x, okay, minus, sorry, 6x. Oh, let's see that. Okay, let me erase that. Okay, it becomes what? 6x minus 2y is equal to what? 10. And then this one remains the same. Okay, so you don't change anything. So that is x plus what? 2y is equal to negative what? Negative 3. So now our system becomes this. All right, so then when we go to the next step, we were going to add these two. All right, so it says add the equations to eliminate the variable. Okay, what we had was what? Was 6x minus 2y is equal to what? 10. And we have for x plus what? 2y is equal to negative 4, negative 3. Let's see, good. All right, so then we're going to add these two equations. Add, okay, this gives me what? 7x, x plus 6x plus x is that. This is plus what? 0, and that is equal to 7. Okay, so now we have 7x is equal to 7, x is equal to 1. Okay, so we have that. Then what do? We substitute this into one of the originals of the original equations, one of the originals. So we're going to substitute it into what? Substitute it into equation 1 and equation 2 and see if we get the same what? The same answers. All right. So first we have what? Substitute x is equal to 1. Okay. X is equal to 1 into equation 1. And then into equation 1, we have what? Equation 1 was what? It was 3x minus y is equal to 5. Okay. Sorry, 5. Okay. So 3 is x is 1 minus y is equal to 5. And this gives us what? 3 minus y is equal to what? 5. And then y is equal to negative 2. Now, if I substitute that, or let's substitute into equation 2. Okay, equation 2 is x plus 2y is equal to negative 3. So x is 1. Okay, it'll be 1 plus 2y is equal to negative 3. Then we subtract 1 from both sides. That gives me 2y is equal to negative 4. And then divide both sides by 2. You get y is equal to what? Negative 2. Okay, so you see that whether we use what? The first equation or equation 1 or equation 2, after we have solved for what? X or one of the variables, any of the original equations will give me the same what? The same results. All right, and then we check our solution again. I'm going to leave that for you to check that. Okay, and then x is equal to 1, y is equal to what? Negative 2. All right, and that is our what? Our solution. Okay, so we have established that if whether we use the substitution method or the elimination, we get the same results, or the graphing. So three methods, three ways of solving system of linear equations or system of equations. By graphing, okay, we can solve by what? Graphing. By what? Elimination or substitution. And then by what? By elimination. Okay, so these three methods could be used to what? To solve for a system of what? Linear or system of equations. All right. Now, I'm going to, next example, we're going to look at how do you identify inconsistent what? System of equations. All right. But before that, let us look at an application. It says that a movie theater sells tickets for $8 each. Okay, with seniors receiving a discount of what? $1. Okay, so that means the seniors pay what? $7. One evening, the theater sold 521 tickets and had a revenue of what? $4,000. How many of each type of ticket was what? Was present? Okay, how many type of what ticket was what? Present? Because there are two of them. Okay, we have what? Discount and non-discounted. Okay, we have non-discounted tickets and then counted what? Discounted tickets. The seniors pay $1 less, so that would be $7. All right, so first we want to let X represent the number of tickets sold at what? At $8. And then you let Y be, that's the solution part, let the Y equal to the tickets sold at what? Discount what? Price, which is what? $7, because they pay less than that. Okay, then the given information results to a system. So first, we'll look at the cost. Okay, we'll look at the costs. Okay, the cost equation. Now, if I have X what? X tickets, and then each is costing what? $8, then what's the total cost? It will be what? 8x. And then if you have Y ticket, this is for what? Non-discounted. All right, non-discounted. Okay, tickets. And then the cost for discounted, that for seniors who pay $1 less, that's $7. That is going to be 7Y, because there are Y number of those tickets sold. So this is for discounted what? Discounted what? Tickets. Okay, so what would be the equation for that? Okay, the equation is the total cost. If you add these costs, this get what? According to the question, you get $4,000. So the equation is 8x plus what? 7y is equal to 4,000. Okay, that gives you one equation. And also we have what? There are number of tickets. Okay, we have a number of tickets equation. Okay, there are X non-discounted tickets and there are Y discounted tickets. But how many were sold that day? It was what? 521. And therefore, that gives me X plus Y is equal to 521. So the system is what? Gives me the two equations, 8x plus 7y equal to 4,000. That's equation 1. X plus Y equals what? 521. That gives me equation what? 2. All right. So now we're going to solve this maybe using elimination. All right. As we can see, I'm going to use elimination. First, if I look at this, the original equation, okay. If I look at the original equation, which is what was 8x plus 7y equal to 4,000. And the other is x plus y equal to 521. Now, you notice that if I want to let them have additive inverses, and I want to eliminate the y, I will multiply the equation 2 by what? By -7. If I multiply this whole equation by -7, then when I add 7y to what? -7y, I get that to be 0. And so that's what I'm doing over here. So we multiply that by that, we get -7x minus 7y equal to -3,006 Then when you subtract, you are going to get what? X is equal to 353. Okay, so but we know that x plus y is equal to 521. So if I substitute x, which is 353, and solve for y, I'll get y is equal to what? 168. So what that means is that how many non-discounted tickets were sold? 353. And how many discounted tickets were sold? That is 168. Now, of course, x plus should give me 521. That is 353 plus what? 168 should give us what? 521. And it must also check for what? The first equation. All right, so that's an application. Now let us go to inconsistent, how to identify or inconsistent system of linear equations in two variables. Okay, so we look at these equations. We have for 7x plus y equal to 4. Now I want you to carefully look at them carefully. The second one is 14x plus 2y is equal to 1. Now what do you see? It seems to get equation 2, we multiply equation 1 by what? It looks like this. To get equation 2, this is you multiply this equation 1 by what? By 2. But when you multiply by 2, instead of this becoming what? 8, it is 1. So that is inconsistent. So that's a quick check. But let us try to solve this and see what happens. So we choose let's say substitution method and solve for y in equation 1. Now if I solve for y, I get y is equal to minus 7x plus what? Plus 4. And let's plug it into equation 2. Okay, we're going to substitute that into equation 2. Okay, substitute that into equation 2. All right, and what would that give us? Okay, let's substitute that into equation and solve. So we have 14x plus 2 times y, which is minus 7x plus 4 is equal to 1. So you get 14x, distribute that, you get 2 times minus, that gives me minus what? 14x, okay? And then plus what? Plus 8 is equal to 1. Of course, if you have negative plus that, okay, this is plus. When you add them, you get what? 0 plus what? 8 is equal to 1. So you get 8 is equal to what? 1. This is false. It's not true. Okay, it is false, or we say that it is what? Inconsistent. Inconsistent, meaning we can never have what? 8 is equal to what? Is equal to 1. It's not true. It's inconsistent. So because of that, this is what? An inconsistent system. So our conclusion is that the system has no solution, and therefore it is what? Inconsistent. Now, when you do the graph, this is what I showed you in the beginning, that when you graph this, the two lines will be parallel, and therefore they will never intersect, and therefore no what? No solution. Okay, then let's look at the other example. But also know that if it's inconsistent, it means that they are parallel, as I said, and they have the same slope. You can solve for the slope for each of them, but they have different what? Intercepts. Okay, the lines have the same slope. When two lines have the same slope, we say that they are parallel. Okay, and in this case, if you graph them, they will not meet, and therefore no solution. Okay, now in the dependent system, now again, consider 1 and 2. It looks like, look at question as equation number 2. when you multiply equation 1 by, say, -3, all right, if you multiply equation 1 by -3, you get what? -12x plus 3y equal to what? -18. So technically, as you see, the equation 2 is a non-zero multiple of the equation 1. Okay, so once you see this, then you can say that this is going to be dependent what? Solution. In other words, it's the same equation 1, but we are replacing, getting another equation by a multiple of that. Okay, so we choose to elimination method to solve this. Okay, if you choose elimination, well, what we have there, let us have, we have the system. We have 4x minus y equal to that, and then we have 4 minus 12x plus 3y equal to -18. So let us multiply this equation by, let me eliminate x. So I multiply this by what? +3 by 3, and that gives me 12x, okay, minus 3y equal to what? Equal to 18. All right, and then I have minus 12x plus 3y equal to -18. So we add them. This stays the same. So you get 0 plus what? 0 is equal to 0. So of course, 0 equal to 0 is true. So we say that it is consistent. Okay. Now, since it's consistent, it's going to have what? Infinitely many solutions. And then when you draw the graph, this is what you get. It is the lines coincide, and therefore the system has infinitely many solutions. And that's because if I have a line, how many points on it? There are a lot of points on it. So that's why it has what? Infinitely many what? Solutions. All right. So here we say that the statement 0 is equal to, it's true and consistent, meaning the original system is equivalent to a system containing one equation, which is the first one. So the equations of the system are what? Are dependent. Okay. Now, in this case, if any values of x and y that satisfy this equation will be a solution. Any. For example, if x is 1, okay, if it's plug in 1, you get y is equal to a -2. So this 1 and -2 is a solution. If x is equal to 0, y is equal to -6, that's a solution. If x is 2, y is equal to 2, that's also a solution. So it goes on and on and on and on. So all these are possible solutions, and therefore this has what? Infinitely many solutions. Okay, that's why we say that. Now, how do we write this? Okay, in our solution. So write the solution of this original system either, okay, when I solve for y will be equal to 4x, okay, minus 6, because you have what? 4x minus y equal to 6, and then solve for y, you have what? 4x minus 6. So if I plug in any x value, I can generate what? Y values, okay? And that is one way. Or we can solve for x in that equation. If you solve for x, you are going to have what? 1/4y plus what? 3/2. And again, if I plug in values of y, I can generate the values of what? Values of x. Okay, so the way we write this solution, we express it in this form. It's an ordered pair such that what? Y is equal to 4x minus 6 for any value of x. That's for the first one. Or we can say that it is what? X is equal to that equation for any value of what? Y. And sometimes we can write them this in this form because it's an ordered pair. Okay, the first one, if I know x, my y is what? 4x minus 6. So that's an ordered pair for this guy. And then for that one, it is what? We know x is what? 1/4y plus 3/2, comma, and then y. So these are all ordered pair. These are ordered what? It's an ordered pair. That would generate all the what? All the solutions on the line. Okay, so this is the end of the first section, the first part of the video, and we'll pick it up the next time. Thank you.